Now let's look more specifically at the end behavior of exponential functions. So first, let's review what we mean by end behavior of a function. If you talk about the end behavior of a function, what you mean is what happens when x gets very, very large or very, very small. And specifically, what we're talking about is x goes to infinity or as x goes toward negative infinity. So let's draw just a graph out here, just a generalized graph of a function. So if we notice here, if we talk about the end behavior of this function, what we simply do is we simply follow this function as x gets larger and larger and larger, and if at some point the function tends toward doing a certain thing, then that's the end behavior. So in this case, what happens when x gets very, very large, y goes to negative infinity, so that's the end behavior when x goes toward positive infinity. When x goes toward negative infinity, let's see what happens. We follow the graph along, and as we get closer and closer, it looks like it gets closer and closer to y equals 0. And that's what we mean by end behavior. So if we're talking end behavior with exponential functions are actually very easy. The way that we set up the problem is we go limit of f of x as x goes to minus infinity is equal to, this what tells what happens when x goes to negative infinity, which is very, very negative and large. And then the limit as x goes to positive infinity of f of x, and what happens. And what makes this particularly easy is that when you have this, you only have 3 possible answers. And your answers are either going to be negative infinity, positive infinity, or the value of the asymptote. And that's it. So what we need to do is we need to remember what our 4 graphs look like. Our 4 graphs are exponential growth, exponential decay, exponential growth flipped, and exponential decay flipped. And if you notice on any one of these, for example, exponential decay, as x goes to positive infinity, y gets closer and closer to the asymptote. And as x goes to negative infinity, y goes to positive infinity. Let's look at this problem, exponential growth flip. That's when y is equal to ab to the x when b is greater than 1 and a is less than 0. When x goes to minus infinity, see how the graph gets closer and closer to 0. So it gets closer and closer to the asymptote. And as x goes to positive infinity, y goes toward negative infinity. So let's do that. Let's just look at some quick examples. Let's do y is equal to minus 10, 1.7, x plus 4 plus 10. If you want to, you can look at what I call the parent function. The parent function is y is equal to minus 10, 1.7 to the x, right? What does that roughly look like? This is exponential growth, but it's flipped, so it's going to look something like this, and this is going to be the asymptote. When we, instead of looking at the parent function, if we look at the actual function, y is equal to minus 10, 1.7 x plus 4 plus 10. Now, what we're really concerned about is not the graph, but the asymptote and the general shape. The asymptote starts off at y equals 0. The h doesn't affect the asymptote at all. The 10 does. So the new asymptote is y equals 10. The graph shifts to the left 4 and up 10. It's going to look something like that. And now we can figure out what the graph is going to look like. What the end behavior is. We say the limit as x goes to minus infinity of f of x is equal to, let's put our finger on the graph and let x go toward negative infinity. See how y gets closer and closer to the asymptote. And in this case, the asymptote's 10. So the limit as x goes to negative infinity of f of x is simply 10. Let's look at the limit as x goes to positive infinity of f of x. Here's the graph. As x goes to positive infinity, what happens to y? It gets more and more negative, so that goes to minus infinity. So that's what makes this a fairly easy problem is that you only have three possible answers. It's the asymptote, positive infinity, or negative infinity. In this case, the answer is 10 and negative infinity. Let's look at another problem. Y is equal to 12, 0.57, x plus 10 minus 14. The parent function, y is equal to 12, 0.57 to the x. That's a simple exponential decay function. It simply looks like this, where the asymptote starts out at y equals 0. When we shift it around, y is equal to 12, 0.57, x plus 10 to the plus 14. You have to see what happens to the asymptote. The 10 doesn't affect the asymptote, the 14 does. The new asymptote is at positive, that's at minus 14, my mistake. That's a minus 14. The 10 doesn't affect the asymptote, the 14 does, so the new asymptote is minus 14. And what happens is the graph essentially remains more or less unchanged. So let's do the end behaviors. The limit as x goes to minus infinity of f of x. X goes to minus infinity. So as x goes to negative infinity, y goes to positive infinity. And the limit as x goes to positive infinity of f of x. Positive infinity, it gets closer and closer to the asymptote, so in that case it's minus 14. And that's how you do end behavior of exponential functions. And here's the key, is that when you have here's what the answer looks like, and there's only three possible answers: minus infinity, infinity, or the asymptote.